Hello, sir. Myself Prakhar Rai, and I am from IIT Guwahati trimester. Currently, I am presenting my trimester 7 project, which I have done. So, my project name was Alethea, a fully local agentic retrieval augmented generation system. So, my name is Prakhar Rai, and my student ID is G23050101110. So, what the problem and what the motivation of doing this project was? So, the problem is large language models are fluent but not ungrounded. And if we ask about a document they have never seen, they hallucinate possible falsehoods. So, what happened is sometimes if we upload a PDF and then we ask something related to the PDF or any financial PDF or any PDF, then the system searches and answer from it. But if we have not seen any PDF and we have not uploaded any PDF, and if you ask about that PDF, then also it answers something. So it hallucinates. So the retrieval augmented generation fixes this by grounding answers in the retrieved passages from the trusted source. But the name receipt embed take top K by cosine stop the prompt break on real document. So what the problem it solved is the RAG system. The RAG system it embeds and it takes top case cosine similarity, stop the prompts and break on real documents such as vocabulary mismatch, dense vector blur exact terms, names and IDs, course ordering, independent similarity scores misrank passages, and single shot retrieval. One query cannot cover multi-part question. So the goal of the our project is to accurate retrieval and multi-op reasoning and verifiable grounding. So the objective of the project is build an end-to-end RAG product over user PDFs, URLs, and notes and answering with inline citations. It implements hybrid retrieval, dense semantic, sparse lexical, used without concealing scales. Add cross-encoder re-ranking for precise ordering of the shortlist. Then introduce an agent that decomposes complex questions into multi-op subqueries. Then it guard against hallucination with an automated faithfulness check and keep it fully local, open weight and compared 340 lines with the fair tier GPU. So we will use T4 GPU here in this project. So what is the architecture, simple system architecture of this project? Is the user feeds its question, then the rank plan subqueries, then dense plus sparse retrieve, RRF use plus re-rank, then synthesize cited answer and faithfulness check, and after that it plan retrieve, use and re-rank, synthesize, and then verify the answer, and then it can give the result. Ingestion and indexing. Structure-aware chunking, pack the paragraphs into 220 word windows with a 40 word sliding overlap. Oversized paragraph are hard split so nothing overflows. Then each chunk keeps it short so answers cannot cite it. Dense index, busy, small embeddings help to normalize search by fast in the inner product and captures meaning. A sparse index that Okapi BM25 over the same chunks captures exact terms. Two complementary views of the corpus built once at ingestion. Then we move on the next step of this project, which is hybrid retrieval plus reciprocal rank fusion. So the dense generalizes across paragraphs, sparse nails exact terms. Their failure modes are complementary. Then it merged the two re-ranked lists with reciprocal rank fusion. Using only one rank position, score D is equal to R, which belongs to the set of R, 1 upon k plus rank r of d, ठीक है, and k is equal to 60. Because RRF ignores raw scores, it slide steps reconciling cosine similarity with BM25 magnitudes, robust and parameter light. Re-ranking and agentic reasoning. Cross encoder re-ranking. Re-score the fused shortlist by reading query plus passage together, far more accurate than independent by-encoder scores. Applied only to shortlist, so the accurate model stays affordable. Then agentic planning. The LLM decomposes a complex question into three sub-focus subqueries. Verbatim if already simple, and retrieve per hop, then pull and deduplicate the evidence. This targets exactly where naive RAG is weakest, compositional questions. Then we move on to the next step, which is grounding and faithfulness verification. So the model's answer synthesis step is the model answer using only the numbered sources and attaches an inline citation end to every claim. Verification and strict fact checking pass compare the answer against its sources and returns one line verification. Grounded a partially unsupported, naming any unsupported claim. When evidence is absent, the model declines rather than fabricates, and result is a visible, actionable trust signal on every answer. Implementation and result. Step. When 2.53 billion instruct 4-bit NF4, BG is small, mini L cross encoder fires BM25 gradio, all open weight and free T4D. So these were all the stacks of what the technology we are using. So we use the model QN253 billion instruct to 4-bit NF4. BGE is small, mini LM cross encoder fires as our open fast API, BM25 and Gradio for implement deploying our open source app. So the hybrid RRF, what it recovers both exact terms and recurrent, plus re-ranking most relevant passage rises to the top, planning better coverage of multi-part questions, verification it flags unsupported claims to the user and put to 340 lines run fully local. The largest gains come from retrieval and rounding engineering, not from local model size. So what conclusion and future work we can do on this project is a genuinely useful production shaped RAG product built compactly on free open weight infrastructure with answers traceable to the user's own sources. The future work is conversational memory for follow-up questions, quantitative evaluation harness, retrieval hit rate and faithfulness, iterative self-correction when the faithfulness check fails, and persistent incremental vector store for large corpora. Thank you.